we are going to continue our study of electrons, and we're working towards the goal of being able to develop a Bohr diagram, or a Bohr model, which is a representation of the electrons in an atom. Okay, so electrons within an atom can change between a ground state and an excited state and back to a ground state, back to an excited state over and over and over again. Okay, so usually an electron is going to be in its ground state. This is its normal, neutral, where it spends most of its time. But if you put energy in, so you excite the electron by providing it with energy, it will enter the excited state. When the electron releases that energy, it goes back to its ground state. When it releases that energy, it also releases a photon. Okay, and we can see the photons based on the color of light that it emits, which, as we learned in our previous lesson, depends on its wavelength. So the amount of energy that it is releasing determines its color. Okay, so electrons exist only in orbits with specific amounts of energy. So we call it the energy level. Okay, so the orbit is the space that the electron travels in, and it has a specific amount of energy within it when it is in that particular orbit. So we call those orbits energy levels. Since they reside in those orbits with specific energies, that means that when an electron loses energy and goes into another energy level, it can only lose a certain amount of energy. Okay, those little energy packets that we talked about, those quanta. Okay, because it doesn't slowly travel into the next orbital, it jumps from orbit to orbit with those specific amounts being released. Which also means that only certain photons are produced as you change the levels. So certain levels represent certain colors. Okay, and it depends on the amount of energy, the energy difference. When it goes from orbit to orbit, it's a specific amount of energy that is released. Bohr was able to calculate the energies, and it matched for the hydrogen atom, okay, which is really, really cool that he did that, because turns out, oops, his calculations only work for the hydrogen element and no other elements, but it was still a super important discovery because it let other scientists build on this work. What's really cool is that each element has a unique emission spectrum. So it's kind of like an atomic fingerprint. So on the last slide, we saw what hydrogen looks like. On this slide, you can see what the helium emission spectrum looks like. So it is unique to each element. They each have their own unique print here. Now let's move on to how we can actually draw a Bohr model. They're called Bohr models because when Bohr did his calculations and discovered those energy levels, he was able to create models of the cells. And we are going to do the same thing. Okay, so how do we draw a Bohr model? Let's do a step-by-step. How do you do this? Step 1 is to draw a circle. This is going to represent the nucleus. Okay, so just draw a circle right in the middle of wherever you're drawing your diagram. Step 2, inside of that circle, write the symbol for the element. We can find that on our periodic table. And then we want to write the number of protons and the number of neutrons that are found in the nucleus of that atom. Okay, so remember, the number of protons can be found on the periodic table. That's your atomic number at the very top of the box. And then you can find your neutrons by doing the mass minus the protons. Then we want to draw rings around the nucleus to represent the different energy levels. Okay, and the rings correspond with the rows on the periodic table. So if the atom you are, or the element you are doing is located on the first row, then it will only have one energy level, so you'll draw one ring. If you are doing an element on the second row of the periodic table, such as lithium, then you would draw two rings because it has two energy levels, and so on. So if you have something on row 3 like sodium, you would draw 3 rings to represent the 3 energy levels. Okay? And then finally, draw your electrons as dots on the energy level rings, and remember that each energy level has a maximum number of electrons that it can hold. So what is the maximum number that they can hold? Okay, the first level, or that first ring, can only hold 2. It's very small, it's very close to the nucleus, it can only hold 2. And then as you go out, they get bigger, they get further away from the nucleus, they can hold more electrons. Okay, level 2 can hold 8, level 3, 18, and level 4, 32. Okay, and that's as far as we're going to go in drawing, because Bohr models are supposed to be a simplified representation of an atom. So once you start drawing out those ones that are really far down on the periodic table, it gets really clustered and difficult to see, so then it's not a simplified version anymore, right? So we're not going to do any that far because we want this to be a simple model. But do remember, this is a simplified version of atoms and those energy orbits. We're going to start here because it's a good introduction, and then we'll take it further and see how we can get more correct with these models. Okay, but today let's just start with the simple Bohr model. So now you know the steps. Let's do an example. Okay, so let's do magnesium 24. So remember, when it's written like this, magnesium, that tells me the element. 24 is my mass. Okay, that tells me my mass. Okay, so magnesium 24. So step 1, draw a circle to represent the nucleus. And step 2, we need to fill in that nucleus. Okay, so magnesium, if I look on the periodic table, its symbol is Mg. And then looking at the atomic number, I know that that's 12. That means 12 protons. I'm going to write 12p. And then to find my neutrons, I need to do the mass minus the protons. So 24 minus 12 is 12 neutrons. Okay. Next step, step 3, I need to draw rings around the nucleus to represent the energy levels. So when I find magnesium on the periodic table, I see that it is in period 3, so I'm going to draw 3 rings. 1, 2, 3. Okay, these are my energy levels. All right, last step, draw the electrons, and remembering what each level can hold. Okay, so with my electrons, I am going to have 12, because this is a neutral atom. So same number of protons and electrons. So since I have 12 protons, I need 12 electrons. Okay? All right. So the electrons want to go to the smallest energy levels first. So you always fill up the inner level before you move to the next level. Okay? So the first ring can hold 2 electrons. So 1, 2. And remember, electrons repel one another, so we're going to put them as far away from each other as they can get. Okay, now I still need more. I have to draw a total of 12. I only drew 2, so I need to add in some more. But now this level's full, so we've got to go to that second level. And 1, 2, 3, 4. Notice I drew them kind of as far apart as they could go on that particular ring. Okay, all by themselves. But now, the next set, they're actually going to pair. So we're going to learn in the future that electrons pair together and then spin in opposite directions. So to fill in the second half of this second ring, we're going to pair them together. So I've already drawn 4 on this ring. There's 5, there's 6, there's 7, and there's 8. So now that level is full. It cannot take any more. 8 is the maximum. Okay, so now I have a total of 10 electrons drawn. 2 on level 1, 8 on level 2. But I'm not done, because remember I need a total of 12 and I only have 2. So I've got 10. So I've got 2 left. So where are they going to go? They're going to go on the third ring, and I'm going to space them apart from each other because they're spaced too. And they want to be as far away from each other as possible at this point. Okay, and I'm done. So this is my Bohr model for magnesium 24.